Hello everyone and welcome to the first lesson of Unit 2, Biochemistry. In this unit, we're going to be learning about the chemistry of life. Remember, bio means life, so biochemistry is going to be the chemistry of life. And we're going to start with our teeny tiny building blocks called atoms. So you should remember from last unit that atoms are the smallest biological level of organization. They are the smallest basic unit of matter. Atoms are going to make up all physical things, both living and non-living. Atoms can be broken down even further into three smaller parts, which are protons, neutrons, and electrons. Now, our protons and neutrons are going to be found in the nucleus of the atom, so in the center of the atom. Our protons are going to carry a positive charge, and the neutrons are going to be neutral, meaning that they have no charge. And lastly, we see these electrons here on the outside of our atom, and these are actually shown a lot closer than they really are. So in reality, electrons are really far from the nucleus and they're really, really tiny. But protons, neutrons, and electrons are our three subatomic particles. Now, when we look at the periodic table of the elements, what actually is an element? Well, an element is just one specific type of atom. For example, carbon, hydrogen, etc. The elements we are most concerned with are going to be CHOMPs. So carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. So we use the acronym CHOMPs to help us remember these elements because these are the most important elements for living organisms. Now, when we go to read the periodic table, we can see it's broken down into rows, which are the horizontal portion, and it's broken down into groups or columns, and these are going to be the vertical portion. So our group numbers here are going to tell us how many valence electrons each atom has. Now remember, valence electrons are the electrons found in the outermost shell of electrons. So atoms in group 1 will have 1 valence electron. Atoms in group 2 will have 2. And we can fill out the rest of our valence electrons here. Now these electrons are going to be important when an atom wants to bond. So if we look at carbon here, carbon has 4 valence electrons, which means it can bond to 4 other atoms. Remember, the outermost shell of electrons can hold 8 electrons, so carbon only has 4, therefore it can bond to 4 other molecules. So we're going to see carbon in every macromolecule that we're going to talk about in this unit. If we look a little closer at each element, we see that there are 4 different parts listed on the periodic table. So first of all, we have our atomic number, which is just going to tell us the number of protons in an atom of that element. We also have a symbol to represent that element. Many of the elements are represented by 1 letter, but some of the elements are represented by 2-letter symbols. We also have the relative atomic mass. Now our atomic mass, if you look down here, is going to be the number of protons plus the number of neutrons. So our atomic mass is looking at the nucleus of the atom, how many protons and how many neutrons together. And last but not least, we have the name of our element. In this example here is hydrogen. So when we change the atomic number, we are changing the element. And each element is going to have a different name because they have different properties. For example, if we look back at our periodic table, carbon here is usually found in a solid state, whereas oxygen is found in a gas state. And when we change our atomic mass here, we are changing the number of neutrons because our atomic number will always be the same. So here we're looking at two different models used to represent atoms. Now you should remember the Lewis and Bohr models from the tic-tac-toe activity you did in the last unit. So we remember that in our Bohr model, this is going to show all the electrons that are found in an atom. So it'll show both the inner electrons as well as the valence electrons. Now our valence electrons are those found in the outer shell. And our Bohr model is actually going to show the number of protons and neutrons as well. So in this example, we're looking at a carbon atom. So actually, both of these are going to show us carbon atoms. But in our Bohr model here, we can see that carbon has 6 protons and 6 neutrons. So since we have 6 protons here, its atomic number would be 6. And if we have 6 neutrons and we want to find our atomic mass, we're going to add together protons and neutrons. So if we add our protons and neutrons here, we would get 12, and this would be our atomic mass, which is the number of protons plus the number of neutrons. So when we look at our Lewis dot structure over here, we can see that only the valence electrons are shown. So only the electrons in the outermost shell are shown. So if we look over back at the Bohr model, we can see we have 4 electrons in the outer shell. So those are the 4 electrons being shown in the Lewis dot structure. Now when atoms link together, we're going to call them molecules. So a molecule is 2 or more atoms held together by covalent bonds. And a covalent bond is going to be the sharing of electrons. So we can look at an example here of H2O, which you know and love as water. So we can see that oxygen has 6 electrons in its outer shell. Now it wants a full shell of 8 electrons so it can be stable and happy. So it's actually going to share its outer electrons with the outer electron of hydrogen and form these covalent bonds here. And in the end, both hydrogen and oxygen will be more stable and more happy. So that is all the material for this lesson, and I will leave you guys with these 2 jokes here.